In this question, we're told the curve C has equation y equals 20 over x plus 2x squared minus 11. The point P has coordinates 2, 7 and lies on C. Find the equation of the normal to C at P. So finding the equation of a normal requires a point and a gradient, since the normal is a straight line. We have a point because it's going to pass through the point 2, 7, but we have to find the gradient. What we're going to use is that the normal is perpendicular to a tangent, and so if I find the gradient of the tangent to the curve, I can find the gradient of the normal. The gradient of the tangent is the same as the gradient of the curve at that point. So we're going to have to differentiate our function in order to find the gradient at that point, and then I can find the gradient of the normal. So first I'm going to rewrite the equation in index form. So that's rewriting the reciprocal as an index form so that I can differentiate it. So plus 2x squared minus 11. Then I am going to differentiate it. So I get minus 20. So it's minus 1 times 20 is minus 20. X decreased the power by 1, which is minus 2. Plus 2 times 2, so it's the power times the coefficient, which is 4. X and decrease the power from 2 to 1, so I get 4x. So I can just rewrite this. It'd be a little bit more useful for calculating with. Dy by dx is equal to 4x minus 20 over x squared. Okay, so now I can find the gradient of at any point on the curve. I need to find the gradient at the point 2, 7. So x is equal to 2. Dy by dx will be equal to 4 lots of 2 minus 20 over 2 squared. So we get 8 minus 20 over 4. 20 over 4 is 5, so 8 minus 5, the gradient is 3. Now, the gradient of the tangent equals 3. I want the gradient of the normal, which is perpendicular to that, so we're going to use that property minus 1 over the gradient. So this could be m1 and m2, or m normal and m tangent. So just substituting in the gradient of the tangent, we get the gradient of the normal is minus 1/3. So now we can find the equation of a line, because I've got a point that the line passes through, and I've got a gradient. So using y minus y1 equals mx minus x1, we get y minus 7 equals minus 1/3 times x minus 2. I'm going to tidy it up and simplify it so I get one constant. So I'm going to multiply everything by 3 to get rid of the denominator and get rid of the fraction effectively. So we get 3y minus 21 equals minus 1 times minus 2 is 2, minus 1 times x is minus x. So just predicting, I can see there's a negative, so it's going to reverse those two terms there. And I'm just going to add 21 to both sides. So we get 3y equals 23 minus x. And so now we have the equation of the normal. Let's have a look to see how this question is marked. Initially, there is a method mark for an attempt to differentiate and getting at least one of these terms correct. And there is an answer mark if you have got both terms correct. Next, there is a method mark for substituting in x equals 2 into the dy by dx in an attempt to find the gradient, and an answer mark if you got that the gradient was equal to 3. Next, there is a method mark for using the property of perpendicular lines, and then the final mark is if you have substituted that in the point and the gradient correctly into the equation of a line. Okay, well, I hope that solution made sense and that you understood how to mark the question.